this is the circuit board for the Sparrow. This is actually one that's going to a local dealer here. It's a demo unit. So there's a couple of differences between this and what we actually produce for the mass market. This is it's a pretty interesting design, in my opinion. For one thing, it has no microprocessor, which means everything is run in hardware mode. We don't use any sort of field programmable gate array or anything of that nature because it's too expensive, and in my opinion, it's a little too noisy. So all of the logic that we use is discrete. Same clock that we're using in the internal clocks and in the micro clock. Same sort of noise suppression techniques. In this case, one of the interesting things that we did is that we're running the analog stage input at a pretty high voltage level. So the input headroom is around 33 dB. And for those of you that don't know what 33 dB is supposed to be, it's comparable to the master section on a really nice console. It's just huge sounding. And then we're using a full 120 dB dynamic range converter, which is about the best A to D you're going to be able to buy these days. There's a couple others that are out there that are 123 dB, but it's difficult for us to get a hold of those in small quantities, so we don't use them. And then we have the SPDIF transmitter circuit here. Same noise suppression techniques, low value bias resistors for the data path, which is actually pretty important. We want to treat the data path just like an analog signal and try to maintain phase relationships and try to maintain signal purity as best we can. So, and then we've got word clock. Excuse me, we don't have word clock out. People wanted word clock out, but we couldn't fit it onto the board. We've got SPDIF out, which is actually a BNC SPDIF. And the reason we chose BNC is because it's a much sturdier connection than RCA. You get a bigger physical ground connection. It's more durable out in the field. And then we've got biphase encoded AES. And power supply section is fairly rudimentary. It's a little bit of a challenge to get the 4 voltage rails out of a wall wart that we needed to, so I had to do a few tricks. But for $650, we think it's an incredible deal. It competes with a lot of the high-end stuff that is probably on your wish list or that you've used in the past. We've gotten good reviews from the engineers that we've sent it out to that are used to using high-end stuff. So we think it's an incredible bargain, and it might not be the most catchy-looking piece of eye candy, but it's guaranteed to give you better sound in your studio. Anytime that we want to track audio in today's environment, if we're using a computer, we have to get that signal into the computer somehow. So what's funny is that it actually goes through a conversion process a couple of different times. In this case, what we're doing is we're converting the analog signal, which is like an AC, a variable AC voltage, right? And we're converting it into another form of voltage that is also variable and also AC, but it's stepped in relationship to a reference voltage of 2.5 volts. And the basic principle is that it's your bit rate divided by your reference voltage, and that gives you both your maximum input and your minimum input. And you'll find that no matter what A to D converter you use. But what we find is that the A to D conversion process is fairly noisy, and it takes a little bit of work to get a good sounding conversion that's free of weird artifacts in the high end, that actually has theoretically or it has a bit depth that's close to the theoretical maximum. Most of the time when you do a conversion process, you might be saying, oh well, it's 24-bit, but it isn't actually 24-bit because that's the theoretical maximum, and it's almost impossible to fully reach that. So what we do is we suppress the mechanical noise from all the transistors switching on and off at high rates of speed. And that cleans up our signal, gives us a nice clean high end, and then once you're, as you know, if you're tracking 15, 20 tracks, 8 tracks even, if you've got noise, if you've got like mid-band hash, that stuff is additive, and so then when you go to mix down, you're like, well, okay, how many plugins do I need to get rid of this or that? And it becomes a real fight to get things like, you know, your kick drum and your bass guitar to sit together well, and you try all sorts of tricks. If you've got good signal path to begin with, it's a lot easier to get a nice, clean-sounding mix. And then when you take it to your mastering engineer, he's a lot happier too, because he doesn't have to fight so much either. So this is a completed Sparrow, and it really, as you can see, it doesn't really have much. I mean, you've got power button in front, you've got your master clock select, and then you've got a rotary switch that gives you your clock rate. Inputs 1 and 2, and then you got power in the back, your SPDIF output, your AES output, and then this switch enables 192 or 176 kilohertz transmission. So very bare bones. And actually, I named it after Edith Piaf. She's one of my favorite singers. Black Lion Audio comes from the movie Amélie. It's the downstairs neighbor's dog. So if you watch the movie and when she goes down to talk to the neighbor, okay, the dog is deceased and stuffed and staring at his master. So.